Hi, my name is Vijay. Today we are discussing about process management. Coming to the process management, um, um, what is the definition of process? The definition of process is a piece of code in execution. Um, that means for running process, it requires resources. Examples such as input, CPU, memory, storage, energy, etc. In your system, the processes are in sequence. Every process generated another process called child process. Okay. I'm explaining about the process management, process life cycle. If one process is started, the process is called parent process. Every parent process create another process called child process for execution of uh, execution of task. Okay. Before that, the kernel allocate process ID to the child process. That means parent have process ID. The parent process generated child process. The child process have process ID also. Okay. That means the parent process share resources to child process to execute the to finish the process. Okay. If sometimes the parent process allocate resources to the child process, but the child process does not completed child process completed the process and does not release the resources to the parent process. That means every execution, the child process after completion of execution, the child process return resources to the parent process. So sometimes the child process not returning resources to the parent process. That means that's the state of condition is zombie process. Okay. Um, for process, what why we are giving process ID for each process? That means for security purpose, kernel allocates process ID to the child process and parent process. Okay. Okay, a parent process asleep while the child process is running. That means the child process doing execution. At that condition, the parent process is in sleep mode and wait for request to the signal when the child process is complete. Okay, that means the parent process in sleep state up to the child process complete the execution. After execution, the child process hand over the resources to the parent process. Okay, at that after completion of execution, the child process is completed. That means parents process is completed removed, and that means the resources of child process take back to the parent process. Okay, and this is about the process table. Here process is allocating resources to the child process and it is in execute mode. After execution mode, process is executed. Sometimes process is executed but a child process does not return back to the resources to the child process. That's why the state of process is zombie process. This one. Okay. And to check the process information, every process are in process states I'm explaining. I have started a new process schedule. That means ready and stop. So sometimes sleep. Sleep means parent process while executing the uh, child process executing the process. The main parent process is in sleeping mode. I already explained about it. This is Linux process states. These are R means running process. The process is either executing on CPU or waiting to run. Okay, a sleeping mode. Task is the process is waiting for some conditions. Hardware request to system resources access. Whenever our signals satisfied the condition, the process into the running. D. The process is also sleeping, but unlike a state does not respond to a signal. That means the process is in sleep mode that does not support the response to the signal. Used only when process interruption might cause an interruptible device state. Okay, these are the process signal, process states: the running state, sleep state, and waiting for the waiting state, like killable process, execute. Okay, temporarily stopped also is one signal. By using top command, I'm showing that. Okay, I just have by top command in past. Yeah, yeah, process ID given by the kernel. The user who is working on its process. This is process table. In this process table, processor 0 to 20. Process ID is 0 to 20. So that's why this is nice value. The process value is less than 20. That process, if the process number value is less than 20, less than 20 means that process is high priority to execute. Here you are seeing minus 20 is there. That means the process of execution is high priority to the process ID. Okay, high priority to execute it. Okay, these are resources, CPU resources, memory resources, and time of process. These is about the RS means resources allocated to the reserve resources, so share resources, and we have seen RSTI. We already discussed about here. The process states defines the RSE. This defines the process state of process. This is virtual memory. VIRT means virtual memory allocated, and these are resources. These are shared resources. Shared is state of the process. Is memory resources. Okay. If you are execute the command top command, the kernel collect the kernel updating his process table. The process table is displayed by the kernel. The kernel every 3 seconds get the process details and display the output in top command. If you want to exit the command, just press P to exit from the command top. Okay. If you want to check the uh, child process ID, parent process ID, just command ps3 command to check the parent and child process. We have seen that these are child process, these are parent process. Okay, and well, let me connect charge it to my laptop. Process then the command is set ps hyphen ex, this was the process. TT1 is editor. That means working technology. Myself, what my users. starting time here, process table. And one more question, one more concept is called memory swap is fully. That means the memory of physical memory of the system is full. Then non-usable spaces, that means non-usable RAM is full. What system is full? What a system do is system access the non-usable spaces from the memory. And that means the memory is not allocated. So the condition is called memory swap. Okay. Mm, explain top command and also history means the history is if you want to check the CPU details, that means hardware details. Let's CPU. So that's why not able to see the hardware information. Here we will be showing the hypervisor KVM. We limit KVM. The hardware level it is showing CPU here instead of hypervisor. There is how many CPUs are there in machine. That's only the hardware information or showing by using command LSCPU. Okay, coming to the jobs. Okay, this is about process management, and I'm explaining about the process table by using type command and switch it to the user. This is one. Okay, now I'm explaining about jobs. Before by using job, you can check how many jobs are working in the machines by using common job items. That means there is no jobs working currently. Now I am giving one task. That means command output is called machine goes to sleep mode within 50 seconds. We have seen that if any command is working, no. That means if the process is running, the terminal is not able to execute another command. So is it process running or not? Is it process running? If the process is running, we cannot able to execute the other. Okay, so that's why you control C. If you want to stop the job, control Z. Process automatically stop. Let us check. We are seeing that with 350 process is stop. I have pressed control Z. Let us check the state of the job. Here I have basic control job to stop the process. Again I am running the process by using command C command 18, 18 number to running the process again. So, there is a process ID. This is job ID. I want to start it again. 2753. Yeah. Now checking the job condition. So already 50 seconds is over, so that's why the state is done. Done state it is. Okay. Let us extend 100. I'm using ampersand to run the job in background. Okay. By using ampersand, you can run the process in background. Okay. If you want to check it, it's jobs hyphen L to check the job condition. Job condition. If you want to stop that by using signals, we can stop the process. Okay. I'm stopping the stop 2759. Here you can check by using signal or process signal to stop the job also. If you want to continue That means you can want to restart the job by using cont command. Cont signal 2759. Okay, let us check. You can see that by using count signal to the signal by applying count signal, and the process is moved to the stop to running state. Okay, if you instead of signal, if you want to terminate the running process, just using command kill hyphen trm process id 2759. It's already started. It's already over. Permitted jobs is ended, so that's why let us extend again, giving stopped. I'm again starting that. Continue POMT process. Okay. Continue POMT 2760. Yeah, it is running. Okay. If you want to quit keyboard quit by using QID. Okay. By using command hyphen QUID job ID to set job ID to some process ID. Okay. Yeah, it is in quit stage. If you want to move it to interrupt state int, you can use. Okay. INT 2760 27. It's already killed, so that's why job is not Java is closed. Okay. Okay. Again, I'm using extend vector. Okay. I'm using numbers instead of signals. Okay. By using command jobs, you can also check the what jobs are running. Hyphen L means with job ID. It displays output with job ID. So that's why I am using instead of signal, I'm using number job ID 2773. Okay. Here you can see that by running job, if you want to terminate the job by using command kill hyphen 9 or kill hyphen 15 to terminate the job. So kill hyphen 15 and job ID to terminate the job. Okay. This is about the job process. Okay. If you want to move the current job, actually, let us okay. If you want to move this job to background or front foreground by using, if you want to move this process to foreground, that means FG real time is not put to run this command. So I'm just explaining hyphen. This is job process ID. This is job ID. So that's why by using, if you I want to run this job as in front row, so that's why I'm using command fg percentage one. That means current running job ID. So the command is running in foreground. So how to find the foreground job is running in foreground means we cannot do any execution execute commands. The command table is not command um, or any command is not working. So that's why the job is running in foreground. I just stop it by using Control Z and again start it. The job control ID. This is job ID 2773. Okay, next. Now it is running again. Okay, I want to run this job in background by using PG and percentage one. You can see that job one already in back running in background. Okay, I want to move it. That means the process is running in background. I want to move to front ground. Okay, it is running foreground. So job is over. Okay, I stopped it. I want to run this process as background. Okay, now I am again starting the process by using will sorry, default just list. Okay, fill hyphen 18 and again starting that job. Okay, just hyphen running state. I want to run this as background. I think this may be running already on background. So yeah, already in background. I just stopped it. Okay, again I'm running under the okay. Oh, sorry. If you want to run the job directly in background by using after adding ampersand at the end of every job process, so they are giving is the that means 4000 seconds the system goes to sleep mode. So that's why I'm using that command. Just add lastly ampersand at last. That means the process is running in background. After firing that command, the output shows that the process ID and job ID is there. Now I'm listing the jobs. These are currently running. One process is stopped. 2782. I want to restart that job. Fill icon 18. 2782. Next, listing that or move to the running state. Okay, this is about the process management. Okay, and who we want to check who is working on that machine. Just who command shows that who is currently running on machine. Currently, users running on working on machines. User user TDUIT2 is terminal 2 is working. This is the terminal 2. It's data for logging. You can check W command to also to check the detail user TTY terminal login time, idle time, the CPU says user location. Okay. Uh, this is about the process management. Now I am ending up my session. Tomorrow we will discuss another concept.